is April 21st, right? Did you guys check? Okay, does anybody have any problems with that date? It's supposed to be done by the university. It should be have no conflict with any other exams at that time. So we are, it's 21st Monday? But it's Monday, right? That's what we, that's what, I believe that's what was on the, and it's in the same room, right? Okay, I'm gonna double check and send an announcement what I have, because that's supposed the date they don't have any conflict with any other classes. Okay? But if you have conflict, just let me know so that we can fix it early. And that's like less than 2 weeks from now. So we're talking about the last week is gonna be the last week of classes. We have only 3 lectures, like Thursday and another Tuesday and Thursday. We're gonna finish chapter 16. I believe we cannot go farther than that. Final exam, as I said before, is gonna include at least one or two problems from chapter 16 about the rigid body dynamics, okay? And the earthquake stuff that we did is gonna include 1 question and 1 or 2 questions over the entire subject of dynamics. No fluid dynamics, okay? It's really good, right? Fluid dynamics, all right. So no fluid dynamics, but you have to have chapter 12, 13, 14, 15, 2 questions from these. Okay, maybe 1 working energy, maybe 1, I don't know, kinematics, 1 fluid, I don't know. Like we will see one or 2 problems, and I think the contribution of these 2 problems is gonna be 30 to 40% of the total number of points. And we are gonna have 15% on the earthquake part, 10 to 15%, and 40 to 50% on the chapter 16, because we didn't get examined in chapter 16. So that has the biggest weight, all right? Does anybody have any questions? Yeah.
I'm looking at the sample schedule. It says it's the 24th.
Thursday, okay, that's better. So the 24th then. So it says in the same classroom?
11:15.
Okay, and what time?
9:45 to 11:45.
Okay, so we have it at the same time. 24th, 9:45 to 11:45. I'm also gonna double check when I go home and send an announcement with the exact dates and what content that is gonna be included. Any other questions?
The total amount of questions you're aiming for is
4 to 5 questions.
okay.
2 on chapter 12, 13, 14, 15. 1 or 2 on chapter 16, and 1 earthquake. So we are talking about 5 questions. So, and the exam is gonna be 2 hours. It's gonna be very long. So don't know. We'll see how much time.
This is definitely starting at 9:45.
Yeah, it's gonna start at the exact same time because I'm sure that this is the time that is gonna work for everybody, and hopefully everyone is gonna make it to the exam. And I hope that no one is gonna ask for makeup. I had a car accident. I don't know, whatever. Try to make it. All right, so let's continue what we started last time. I'm gonna solve another 2 problems. Look how many problems I have been solving. I spent the whole lecture last time solving problems. I'm gonna spend half of this lecture solving problems. 3 questions last time and 2 questions this time. So there's a lot of room of questions that been solved in the class, and try to focus on these problems first, and then the homework, and then do other problems, okay? All right. So this question is from the Hitler textbook. It's example 1610, problem 16. This is the non-solvent problems in the textbook. So it says that you have an instant. Okay, so you have a disk here, or a pulley here. Let's say it's fixed. All right, and it's connected with a cord with another small one, and this small one is a part of a bigger one, something like this. All right, and there's a hinge in the middle here. Look at this mechanism. This one is gonna rotate. Let me put the radius. This radius is 50 millimeters, and this one is 40, and this one is 60. 50, 40, 60. And the mechanism works that way. This is small disc is attached to the bigger disc. I'm not sure if you guys have seen this before. Sometimes you see like a big disc that has a little bit of a small flange coming out of it. They are all one system. They are attached to each other, like one piece of metal. But this one is not attached to this one, it's attached to the small one. But once this small one rotates, it's gonna rotate the whole body, okay? So let's understand the mechanism. It says that this is pulley A, okay? And this is pulley B, and this is pulley C. And what's given in the problem? It says at any instant, omega A is equal to 5 radian per second. So this body is moving with a 5 radian per second. Pulley A is given a constant, look at this, it says constant angular acceleration. That means that alpha A is constant, and it's equal to 6 radian per second squared. Determine the magnitude of acceleration of point P on pulley C. Okay, so it says that we have a point P here. Basically, he named the whole system this. He named it SC, like this one, and named this point B. But I'm gonna name this pulley B as well, because C is different from B. But let's say he has a point P here, a random point on this part, and is asking determine the magnitude of the acceleration. When I say the magnitude of the acceleration, do I mean tangent, normal, or total acceleration? Total acceleration, that means at the end you have to get A, which is the square root of the tangent square plus the normal square. Okay, find A at B. Find the magnitude of point B, okay? When A, okay, look at this, I'm giving you a condition. When A rotates 2 revolutions, so when A rotates 2 revolutions, and I'm giving you, all right, so I'm giving you that A is gonna be like, yeah, at this point, and A is gonna make 2 revolutions, that means it's gonna make 2 cycles, all right? And I'm giving you a piece of information saying that pulley C has an inner hub which is fixed to the outer one and turns with it. That means like I'm confirming with you that C and B are one body and are moving the same, and their movement is the same movement. So what I can get from this, I get from this that the omega of C equal to the omega of B, and the alpha of C equal to alpha of B. They both have the same rotation in terms of velocity and acceleration, same angular velocity and same angular acceleration. So basically, if you find out any information about C, it's gonna give you information about B, okay? All right, let's use this piece of information. When A rotates 2 revolutions, find the acceleration of B. But let's find out, what does A rotates 2 revolutions mean? When I say something is rotating 2 revolutions, that means it's gonna make theta. And every theta is gonna make 1 revolution. Is how many pi's? 2 pi, right? Because we are making 1 whole cycle. 1 whole cycle 180 degrees 1 pi, and 360 is 2 pi, and another 2 pi, that means 4 pi. So that means this body started at rest, like let's say theta naught is equal to 0. Like this body, start here, theta is equal to 0. And make 1 revolution and 2 revolution, that means that theta final is equal to 4 pi. That's what I get from this piece of information. Try to translate the information in the problem, okay? So I have theta naught and I have theta. So the next step is, it says, okay, the first thing it says, at the instant, omega A equal to 5 radian per second. So the thing is, I give you at this instant, well, yeah, at the instance with the initial instant, that means that omega A node is equal to 5 radian per second. The thing is, I want to find out what is the omega A when theta was equal to 4 pi. I don't know it. What is the alpha A when theta is equal to 4 pi? I know the initial one. I know it's given theta node is equal to 0 and given omega A node is equal to 5 radian per second. Okay, since you have initial conditions and some final conditions, I want to use them to get these final conditions. If you guys remember, we had a rule that connected all these stuff together. This rule was like half omega A squared minus omega A node squared is going to be equal to, you guys remember? I don't remember. It was A, not A, it should be alpha. Well, actually the one that has the acceleration, it was AdS equal VdV, right? That's what I know from linear velocity. It has a similar one for angular, it was alpha d theta equal to omega d omega. That is the one for linear, that is the one for radial. Look how I thought about this problem. I don't remember this one, but I remember this one. So I got the radial one, and I integrate both sides. By the way, all these equations, this one is in the equation sheet, but I tell you if I don't have the equation sheet how I would think. So this one, when I integrate it, is going to be half omega squared minus omega node squared, and this one is going to be alpha, integration from alpha d theta, and here theta node to final theta. But since alpha is constant, because here it's given alpha A is a constant in the problem, so I can take it out and I can say that this is equal theta minus theta node. That's the rule. That's the one that I want to put here. This is equal to alpha theta minus theta node. All right. So let's see what I know here. Half omega A, I don't know it, but I know omega A node at the initial instant. So minus 5 squared equal to alpha, which is constant, 6 radian per second squared. Theta final is 4 pi minus 0. So I can get omega A. Once you calculate this, so I use the initial and final condition to get omega A, and it's 13.29. 13.259 radian per second. All right, so right now I know what is the value of omega. So right now you know omega A, and I know that's omega at the final instant, but alpha A is constant. We also know that alpha A is 6 radian per second, doesn't it change? Per second squared. So I know omega and alpha for disk A. So can you tell me how can I get omega and alpha for disk C even that I know the omega and alpha for disk A? What is the relationship? It's a very easy one. Well, actually it comes from the velocity.
Omega A times the radius is omega B times.
Excellent. This velocity equal to this velocity. VA equal to VC, and VA is equal to omega A multiplied by RA, and VC is equal to omega C multiplied by RC. And both of them are equal to each other, so I can say here for poly C that VA equal to VC. That means that omega A multiplied by RA equal to omega C multiplied by RC. Same thing with the alpha. AA tangent equal to AC tangent. and this is equal to alpha A multiplied by RA equal to alpha C multiplied by RC. So that's an easy to solve. All right, I know omega A is equal to 13.259, and the radius, by the way, the radius RA is 50 millimeter. By the way, I can put it here 50. I don't have to convert it. I'm gonna tell you why. 50, and this one is equal to omega C multiplied by RC, which I know RC is given as 40 millimeter. I'm gonna put it 40. Can you guys tell me why I didn't convert it to meter and I left it millimeter? The thing is, once I have it in both sides millimeter, that's fine. You cannot convert one and leave one. Because this quantity is the same unit of this quantity, and this quantity is the same unit of this quantity. So I have the unit radian second millimeter, here radian second millimeter. So they are equal to each other. If you want to be consistent and convert them to meter, that's fine. Okay? But as soon as I have this is equal to this, or be like the same unit, that's fine. If you convert them and make it 0.05 and 0.04, it's gonna give you the same answer. So basically, I can get omega C from here and see how much does it equal. But let me ask you something. What do you think about omega C? Is it gonna be bigger or smaller than omega A? It's gonna be bigger. Because you have a bigger disk, it's gonna transfer all the motion to smaller disk. So it's gonna has much higher velocity. That's how the bikes is going. You bike on the big gear and give it to the small gear so that the bike can run. And actually, you know what? This is actually like the bike problem. Thing is, the difference is the bike has the two wheels as the same size. No, actually, this is smaller. I mean, like much smaller than this one. But you have a big gear is giving the motion to a small gear that it attaches to the big wheel of the bike. All right? Okay, so I can get omega C. Same thing with alpha. Alpha A is 6 radian multiplied by 50 is gonna be alpha C multiplied by 40, and then you can get alpha C. And this is gonna be equal to, the numbers are 16.57 radian per second, and the alpha is gonna be 7.5 radian per second. Okay, I got C, but actually in this problem it doesn't want C. You want to find the acceleration at B. Okay, so the acceleration at B, to get it, you have to use the alpha and the omegas that comes from here, because it sounds like this one this is gonna have alpha C and omega C, right? And actually I can say here that this is equal to the omega B and also equal to the alpha B. Right, how we can find the tangent acceleration at B? To find the tangent acceleration, it has a rule, if you guys remember. A tangent at any point, let's say P, is equal to the alpha at B cross product dr the radius. But right now, let's only do magnitudes, not direction, because we already know the directions. So let's put it that way. Alpha B is equal to alpha C equal to 7.5. But right now, the radius at B is much bigger. From 40, we're going to 60. And I'm gonna convert this to meter. I'm gonna make it 0.06. I'm gonna find what is the value of this. And I'm gonna find the normal acceleration at B, and that's easy to find. To get the normal acceleration at B, if you guys remember, it was equal to omega cross by B, and we converted this to omega crossed by omega crossed by R, because V is equal to omega multiplied by R. So basically, the magnitude is equal to omega squared multiplied by R. And this is coming from this rule. If you guys remember, A normal is equal to V squared over rho, which is R, and V is equal to omega multiplied by R, which is squared is gonna be omega squared R squared over R, and this is omega squared R. So this is the same like this one. We didn't do something new, right? And by the way, I have a tip for you. The thing is, if we are trying to find directions, you have to multiply a vector by a vector. cross product. It takes a lot of time. And once you get a new vector, you multiply it by omega again, which takes more time. There's a shortcut for this. If you want to do this as a cross product, we always say that this is equal to the omega squared multiplied by the negative R vector. And this one doesn't include any dot product. The A normal, the normal acceleration at any point on a disk is equal to the omega squared, and it's in the negative direction of the R. And that makes sense. If you have a disk like this, and this is the center of rotation, and this is the point that we are trying to get the normal acceleration at, this is R, right? It goes this direction. The A normal is always going in the opposite direction of R, that is the A normal. So basically, if you get omega squared, and you have R, multiply them as a dot product, like magnitude, and always put the direction in the negative direction of R. Do you guys got that? Okay. Alright, anyway, I'm not interested in the direction right now, I'm only interested in the magnitude. So the magnitude is gonna be omega squared is gonna be 16.57 squared, and this multiplied by R, the radius is 0.06. So the radius is gonna be 16.48. Radian per second. Oh, sorry, that's not radian, that's acceleration. Let's put the values here. So right now we have the tangent and the normal. If you want to get the A total, it's going to be the square root of A tangent squared plus A normal squared, and this is going to give you the square root of 0.45 squared plus 16.48 squared, and this is going to give you 16.48 meters per second squared. And the thing is, if we want to put this here and see how this is going to look like, the thing is the tangent is going to be that way, that's A tangent, and the normal is going to be that way, A normal. If you want to know the directions of them, the theta, so the theta is going to be the tan inverse of the A normal on the A tangent. So you are going to get the tan inverse of 16.48 over 0.45, and then that means the theta is going to be 88.43 degrees. So if you want to know the direction, definitely the direction between them, and you are going to move 88 degrees from the tangent, so it's going to be something like this. That makes sense. Why? Look at the tangent acceleration. It's very, very small, and the normal acceleration is very, very big. So the direction is going to be more towards the normal acceleration. It's going to be like almost at 90 degrees. All right, so that's solving problem that has gears.
Where did you convert the radius?
Oh, you are saying I put it here millimeter and then?
Yeah, and then
Okay. The thing is, because here we are having two quantities equal to each other. So I have millimeter here and millimeter here. But right now, I'm trying to find the acceleration in meter per second squared. If you are gonna keep it millimeter, you can keep it millimeter, but you have to put millimeter here, and keep everything in millimeter.
Oh,
Okay? It's gonna be the same. But here, it wasn't worse the conversion, because I have the left side and the right side. Okay. Yep.
Oh, and you have in the diagram for for C, that's alpha C times CC or RC?
No, alpha C, and this should be omega C.
Oh, okay.
It should be omega C and alpha C is going that way.
Okay, thank you.
Okay, I'm solving another problem. And this this is example 16.5 from the textbook. Alright, this example is a little bit interesting. It's about hydraulic window, one of these old windows. Alright, let's say this is your house. Alright, and you have a window here. This window is a glass window attached to a hinge here, and the window is something, it's a glass, and it's something like this when you open it. This is the glass, it's gonna be, so it's gonna come here, alright? And in the middle, there's a hydraulic arm. This hydraulic arm is from here to here, and it has something like this, and then there's something is coming out of it like that, okay? So the thing is, when you close this window, the bar is gonna go inside the hydraulic and the window is gonna close. But when you open it, this one is gonna go all the way up, all right? So let's see, what is the question saying? It says, let's put some dimensions. So it says, so what is the arm that is changing in length? This one or this one? The window doesn't change in length. If I'm saying that the window height is 2 meters, to this glass thing is 2 meters as well, doesn't it change in length? And the middle is gonna be like 1 and 1. So basically I don't have to tell you this dimension. If I told you this dimension, basically you can know this dimension on your own, okay? So that's the first thing. Second thing, the thing is that I don't know what is the arm length of this one. Because this one is keep changing in length. It depends on how much you are gonna open the window. So this arm changing in length. And what also is it changing? The theta of this window. It depends on how much you are gonna open the window, and this depends on S, it's gonna change the theta. So the more the S is gonna increase, the more the theta is gonna increase. Alright, so I only give you one dimension, that's 2 meters. And I say the large window in figure 16 is opened using a hydraulic cylinder AB. So this is A, B. If the cylinder extends at a constant rate, 0.5 meters per second, that means this one is moving at a constant rate. By the way, this is a linear velocity. The arm is increasing in length. Vs is equal to 0.5 meters per second. Like this length is increasing 0.5 meters per second. Determine the angular velocity and the angular acceleration of the window at the instant when theta is equal to 30 degrees. At theta equal to 30 degrees, when this window opens 30 degrees, determine how much is that omega and how much is the alpha, the angular velocity and the angular acceleration. Okay, so that's what is given. All right, let's see how we can solve this problem. Well, we have, the thing is I give you Vs, and I want to, I give you information about the cylinder, about the hydraulic arm, and I'm asking you information about other things. I attach it to this arm. So the very stuff that is gonna come to your head, how can I relate the movement of the arm with the movement of the window, right? That's the very thing, because I have nothing to do with this. I'm not asking about the omega of this arm. I'm asking you how this window is moving. So what is the two variables here and here? What is the variables that I have? If S is increasing, what is gonna happen? Theta is increasing. So I wanna find a relationship between the velocity S and theta, how theta is increasing. That's the very thing that I wanna find out. All right, it's gonna take us to do some geometry, okay? All right, let's say this is the 2 meter window, right? Here. And let's say open this and came here, okay? All right, and I have, this is the middle, and then this is the middle here. hydraulic arm is from here at the base and goes all the way up here and has length F. And I have theta. And this is perpendicular. This is 90 degree. Do you guys know how can I find a relationship between S and theta from the geometry? Alright, let's figure it out together, right? I know that this is 1 meter, right? And this is 1 meter. Can you tell me what is this length? This length. From the geometry, you know that this is theta, this is 1 meter, and this is a triangle that has a 90 degree here.
If that one's in the middle, the angle is gonna be the same for both sides. Like theta is gonna be
This
the same.
angle?
Yeah.
No, it's not gonna be the same. If this, oh, you mean like if the thing is, no, it's not gonna be the same, it's gonna be different. Because this length is different from this length. Okay, so what is this length? 1 cosine theta. Can you tell me what is this length? 2 minus 1 cosine theta, right? What is this length? The red line.
Sine.
1 sine theta, right? So I can say that s squared is equal to, this is triangle, Pythagorean theory, is equal to 2 minus 1 cosine theta squared plus 1 sine theta squared, right? That's right? Geometry, basic geometry. Can we expand this bracket? It's gonna be, can you guys tell me when you expand this bracket what it's gonna be? 4, excellent. Then minus 2 multiplied by 2 multiplied by cosine theta, then plus cosine squared theta. So this is squared plus this is squared plus this multiplied by this, okay? Okay, then plus this is squared, the sine is squared. Can you guys tell me what is this value? Cosine squared theta plus sine squared theta? 1, right? So this is 1. So you're gonna have s squared is equal to 5 minus 4 cosine theta. That is the relationship between s and theta. You see, from the geometry, I was able to convert s to theta. If I know what is the value of s, I can know what is the value of theta, right? So the thing is, I'm not given s, I'm given vs. How much s? The distance is changing over time. It's 0.5 meter per second. So when I convert it from distance to velocity, what should I do? Have to differentiate with respect to the time. So you need to do one level of differentiation. Take ddt for both sides. Can you guys take ddt for both sides? Basic differentiation. Can you differentiate s squared with respect to the time? By the way, I'm not differentiating t squared. I'm differentiating variable s with respect to a different variable t. S squared, differentiate ds, differentiate s squared. When you differentiate x squared, it's gonna be 2x. S squared is gonna be 2s multiplied by
D over
ds dt. Why? Because I'm differentiating with respect to a different variable. If I'm differentiating x squared with respect to x, it's gonna be this. But if I'm differentiating dx squared with respect to dt, is gonna be 2x multiplied by dx dt. Here, I said it many times, here's dx dx, and this is equal to 1. Alright? Same thing here, it's gonna be 2s dx dt. And this is gonna be equal to, what is the derivative of 5 with respect to t? 0. What is the derivative of this with respect to t? Differentiate it like any normal variable you differentiate it. What is the differentiation of the cosine? It's gonna be, the cosine is negative sine, right? So it's gonna be plus 4 sine theta multiplied by d theta dt, because this is theta and this is t, they are not the same. Alright, so I have here 2s multiplied ds dt, that means this is vs, equal to 4 sine theta, and this is theta, d theta dt is omega, right? Okay. So I got the 1. The second one, I want to have an equation that has alpha. So how can I get this? You have to differentiate this one more time with respect to the time t. So I'm going to do the same thing. 2s. This is two variables, s and v. So I have to differentiate the verse and multiply by the second, differentiate the second, multiply by the verse. So this is going to be 2 vs ds dt plus 2s, and then when you differentiate dv is going to be dv dt. When you differentiate, it's going to be something like this. That is the both side, the left hand side. And the right hand side, you have to differentiate this first. So this is going to be 4 cosine theta, and you're going to have d theta dt, and there's omega, so you're going to have omega squared, because once you differentiate this, you're going to end up with another d theta dt outside, and that means there's 2 omegas multiplied by each other, plus 4 sine theta multiplied by d omega dt. What did I do here? Okay, let me tell you, I have done this before. I told you, if you are differentiating two variables, let's say z equal to x and y, x multiplied by y, and you want to differentiate this with respect to the time. This dz dt equal to differentiation of the first dx dt multiplied by y plus x multiplied by the differentiation of the second dy dt. That's a basic differentiation rule. Derivative of the verse multiplied by the second plus the verse multiplied by the derivative of the second. That's basically what I have done. This derivative is here. Let's see what. Oh yeah, I put 2 and vs alone, and then I put ds dt, and then here I put ds, and then I get the differentiation of this. All right, let me look at the problem again. It says, I want to know if there's acceleration, because this is dv dt. It says that the arm and the cylinder extend at a constant rate velocity. V is equal to 0.5, and it's a constant rate. What does that tell me about the acceleration es? It's constant velocity. That means it's 0. So dv dt is equal to 0. I know this for sure. All right, so, and I know already Vs is equal to 0.5, so 2 multiplied by 0.5 is going to give you 1. So, and this is also Vs, like actually ds dt is going to give you another Vs, and basically that means we have Vs squared, 2 ds squared. So the second equation is going to be 2 Vs squared is going to be 4 cosine theta omega squared plus 4 sine theta alpha. And this is the second equation. So I got another equation that is function in alpha. All right, so right now I'm able to relate between the velocity of the bar with the omega and the alpha of the bar. So let's continue solving the problem. Alright, let's see how we are going to use these equations. The thing is, this problem is asking to determine the angular velocity, omega, and alpha. Let's see what we know in this equation. We know theta because it asks to know that at theta equals 30 degrees. So basically I can put here theta is equal to 30 degrees. I know Vs. Vs is equal to 0.5. So the only unknown that I don't know right now to find omega is S. What is the value of S? And that's basically easy. Alright. You already know that theta is equal to 30 degrees. So if you want to find S, I have the relation between theta and S is here. So S squared at theta equal to 30 degrees is going to be equal to, let's actually put it S. I'm going to take the square root. It's going to be equal to the square root of 2 minus cosine 30 all squared plus sine 30 squared. And then you will be able to find the value of S is equal to 1.239 meters. That actually makes sense. This, at 30 degrees, you have this one, so this is gonna be a little bigger than the one. Because S, tell me, what is the smallest value of S? Okay, you know, what is the smallest value of S? 1 meter, right? Because it's gonna be here in the middle when theta is equal to 0. Like if you put theta is equal to 0, cosine 0 is equal to 0, and sine 0 is equal to 0. Sorry, cosine is equal to 1, and 2 minus 1 is gonna be 1, and this is 0, root 1 is gonna be equal to 1. And that makes sense because it's gonna be here in the middle. Alright, so I was able to find the value of S, so basically I can substitute in equation number 1 from equation number 1, I can say that I have 2 multiplied by 1.239 multiplied by Vs equal to 0.5 equal to 4 sine 30 multiplied by omega and omega is going to be equal to 0.6195 radian per second. And then from 2, I can find the angular velocity, which is going to be 2 multiplied by 0.5 squared equal to 4 cosine theta cosine 30 multiplied by omega squared, which I just got 0.6195 squared plus 4 sine 30 multiplied by alpha. So the only unknown here is alpha, and alpha is going to be equal to negative 0.4147 radian per second squared. All right, let's see what we get here. Basically, I give you in this problem information about a bar that is moving, a cylindrical arm, and a window that is moving with an angle theta. I tried to relate using geometry between S and theta. Here, this is the geometry. I was able to find a relationship between them. This one, I differentiated once to get omega and differentiated twice to get alpha. Then I used the boundary conditions given in this problem about theta and about the velocity and about the acceleration, substitute in equation 1 and equation 2, was able to get omega and alpha. That's as simple as that. All right. So in this chapter, or sub-chapter, we are going to talk about relative motion analysis. Basically, we are going to talk about the general plane motion of a rigid body. So most of the rigid bodies that we dealt with right now, it's fixed axis rotation. Either the wheels, it's fixed axis rotation at the desk, center at the desk, and moves around the center. This window, it's moved around the center, okay? So it's attached to something or a hinge that can having a fixed axis rotation. But what if we have a body in the space that moving, maybe translate or maybe rotate, right? So that's the relative motion analysis. Okay, so but before we do this, let's have some illustration about this body. So okay, we have a body AB, and this body AB is moving in the space. Okay, this is the space that this body is moving in. We need to describe the movement of the body. The thing is, this body has a point at the start, a point at the end, A and B. I can actually describe the point A, like I can make a line from the origin here and say that this is the position of RA. Same thing about B, I can say that this is the position RB. But the thing is, A and B, they have a relationship. Like sometimes, like this one is gonna be something like this. So basically, there is a line from A and B is something like this. We can call it, that's what we call it, that's relative. We are gonna try to find out what is the relative position of B with respect to A. Okay, so this is called RB with respect to A. This is how we write it, and this is the direction that we do. The thing is, the magnitude from A to B is constant, unless this body is a shrink. I mean, like, is it shrink or extend? So these points are gonna be far from each other or close to each other, and this is not the case here. The magnitude from A to B, if this bar is 5 meters, so the magnitude is 5 meters. So what is it changing is the direction. This one might be like this or might be like that. So that's why we put a vector, and we said this is the relative location of B with respect to A. And based on the vector analysis that we have here, let me ask you, so if I have point A and I have point B, I want to go from A to B, you can go that way and you can go that way. And this is like an intermediate point, let's say C. So the vector RAB is equal to the vector RAC plus the vector RCB. So if you wanted the distance from here to here, that's the vector analysis. You basically sum this vector with this vector. That's gonna give you this vector. Do you guys understand this? This is the basic vector analysis. Sometimes, if you like, you can go that way and you go that way. If you sum this vector with this vector, it's gonna give you the same as this vector. Okay? Same thing here. I can say that RB vector is equal to the RA vector plus RB with respect to A. Because to get from this point to this point, I can go this and this. If you want to reverse it and you want to get RA, so it's going to be RA is equal to RB plus RA with respect to B. So this vector needs to face the other side, alright? Okay, since we have these vectors that way, we can take the time derivative of these vectors, and this is going to be VB is equal to VA plus VB with respect to A. That is the velocity version of this body, and the same thing with the acceleration vector. The acceleration of B is going to be equal to the acceleration of A plus the acceleration of B with respect to A. Do you guys got that? All right. But let's actually deep dive into this to understand this motion. Okay. Let's say that we have a bar let's say that I have this bar, made a movement, I don't know what kind of movement that this bar did it, to move from this position. I feel that this is a little bit longer. Let me extend this a little bit, because it's the same one. This bar made a movement from here to get to here. So this is point A on this part, and this is point B on this part. And somehow, point A moved it from here, came here, and point B came here. Now look at this movement. So I'm gonna think about it as I told you before in the last lecture. I have these two bars. This is the original position. It was something like this here, and somehow this bar moved to make a movement to come here. So we can analyze this movement into two movements. We say that this bar made a translation to come here until this point came on top of this point, and then made a fixed axis rotation to come to this position. So the bar was like here, and it came like a translation, something like this or something like this, until it comes here, and then make the rotation. So basically, look what is gonna happen here. I'm gonna make, this is gonna be something like imagining that this bar came here, like this, and this point B moved that way, assuming that this line is equal to this line, because this bar is gonna come that way. This is B dash, and then somehow this bar is gonna make a fixed axis rotation omega, so that this point is gonna come here. So you did this movement onto two movements, right? And all this to make this triangle. Like we have a triangle here, another one here, and this is actually the right one. So the symbols that we have here. So this distance, I'm gonna call it DRA, all right? And this is a vector. And basically, this is equal to this because it's a translation. So this part is also equal to DRA. All right? What is DRB is actually the distance from this point to this point. That is DRB. That is the actual distance. And this is from B, like from A to B, and we are gonna call this the DRB with respect to A. So basically, we did this movement RB on two movements. Like we made point B to move to this point, which is a distance similar to this distance, so I can have a translational movement, and then with fixed axis rotation, I was able to come here. So basically, I'm making a superposition of two movements, all right? So let's say if you have a body, this is marked by something, let's say, like this, and look at this movement. This movement, you are gonna have, for example, VA is gonna move that way, and let's say VB is gonna move that way. If VA and VB is like, if you have a body, if you have a body like this, and VA and VB are equal to each other, it's gonna move that way. But if you have different velocities, this body is gonna have a general translation motion. VA doesn't equal to VB, so you are gonna have. So how can I convert this in a motion that I can do some analysis on it? So basically, this is gonna be equal to two motions. This motion is the first one is a translation. This translation is gonna be VA, and here you are gonna have another VA plus another translation, like let's say this body, something like this. This is gonna be fixed axis rotation, and it's gonna have omega, and you are gonna have A and B. And that's what we have here. This body is gonna have, this is a translation with the velocity of A up and down until it comes here, and then the velocity of A is gonna be 0, and this body is gonna come with an omega to the original position. So we analyze the motion into two separate motions. One is a translation, and both points are moving with the same velocity in the same direction, and then another one, VA is 0, and then it's gonna make a fixed axis rotation movement to come to the original position. So what I'm getting from here, by the way, what is the omega, or what is the velocity here? Like let's say the velocity here. So basically this is, we call this omega and omega AB. The omega of the body AB. And the velocity here, V AB, is equal to omega AB cross product R AB. And that makes sense. Why? If you want to find the velocity that you have here, basically you have to multiply this omega by this radius from A to B. So what I'm getting from here, I'm converting this equation. VB is equal to VA plus the omega AB crossed by RB with respect to A. And I mean by RB with respect to A because this is the center and this is the vector, and the vector goes to B and it's with respect to A. Did you guys got that? If you didn't get it, you have to memorize this one. That's cool. The velocity of, like if you have a body and this body is moving in the space and this is the second point, the velocity at this point is equal to the velocity at this point plus the relative motion part, omega AB. Thing is, to get from here to here, this body have to make a VA, all right? And then have to have the relative motion part with the omega multiplied by R to come back to this position.
When you did the fixed axis rotation, is that DRB over A?
Which one?
The red, where the rotation.
This one?
Yeah.
This is DRB with respect to A.
Okay.
Okay, which is this part. This is A and this is B, so it's B with respect to A. Because this and this are equal, because this is the translational movement. So this piece and this piece are equal, and this piece is the relative motion part. So basically I'm saying that the velocity at B is equal to the velocity at A until it comes here, but you have to sum the rotational component, this component. Okay, let's see how this is going to help us in the problem. I'm not going to solve problems, but I'm going to do some illustrative examples. And how this is needed to just map the velocities and the acceleration. Let's say this part is very, very important to understand all the following parts. Okay, I have done this before. Like if I have 3 bars, bar like this, and bar like this, and another bar like this, and they are hinged, something like this. Alright? And I told you this is point O, this is A, this is B, and this is C. Alright, and I give you only one piece of information. I told you, I give you all the dimensions, but I told you this is the omega of OA. Okay. I would ask you, what is the velocity of B? By the way, tell me, what kind of motion does this body have? Is translation, fixed axis rotation, or general plane motion? This is a bar attached to a hinge, and this is a bar attached to a hinge, and this bar attached to these 2 points. What is the motion of this bar? Is it translation, fixed axis rotation, or general plane motion? Fixed axis rotation, because fixed, there's like rotation around this one. How about bar BC?
Fixed.
Fixed axis rotation. Excellent. How about bar AB? Is it fixed axis rotation?
No.
Is it pure translation? Is it general plane motion?
Yeah.
Yes. Why? Because this bar is fixed here. So point B is going to be moving that way. And this one, point A, is going to be moving that way. But the thing is, it's not fixed axis rotation. They are moving with translation and rotation. Both of them, it's a general plane motion. Alright? But the thing is, if you wanted the absolute velocity of B, I know that B for sure is going to move that way, right? There's no way that B is going to move that way or that way. Why? Because this bar, I'm saying that this bar is attaching me, so definitely this point needs to go down. That's a fixed axis rotation. How about point A? If I know that omega is going that way, so definitely A is going that way. Alright? If you know these omega. So this is omega OA and this is omega BC. How about bar AB? What do you think how it's gonna turn? Knowing that VB is going that way and V is going that way. This bar definitely is gonna rotate that way, right? But what is this omega? Because this body is not fixed axis rotation. This body is a general plane translation. So this is the part of the omega that comes here when this body made that way, and we call this omega AB of the body. All right. So the omega AB of the body, if you want to find the velocity, look, this is VB with respect to C. And since the C is not moving, I didn't put C here, okay? This is VA with respect to O, and since O is not moving, I left it VA. Since it's not moving, it's a zero movement point. But the thing is, if you want to find the velocity of B with respect to A, so basically you have to know where's the omega direction. I know that omega is that way. And you need to draw a perpendicular point. This is the arm, AB. This one is called VB with respect to A. This is the direction of B with respect to A. And V with respect to A is equal to the omega AB multiplied cross product by RB with respect to A. This from this. And I put it here, VB with respect to A, because A is moving. So every time interval, A is a change in the position, and VBA is a change in the direction. That is the only new thing in this lecture today. That the relative velocity of this point with respect to this point. So there's a huge difference between the absolute velocity of B and the relative velocity of B with respect to A. Okay? All right, so let me see if you understand this concept. Let's say and by the way, when I draw VBA, that's a perpendicular line on this arm. And this is a perpendicular line on this arm. So if you want to find VB, VB is based on this movement, and VB is equal to the omega BC cross product RC B. Why? Because I'm getting VB from this arm. But if you're getting it from this arm, so VB with respect to, by the way, this is VB with respect to C, but I didn't put C because C is not moving. We don't relate or do relative velocities with respect to a non-moved body. We always do relative if something is moving to each other. Okay? Alright, so VBA is equal to the omega VA crossed by RB with respect to A. Alright, let me do something else. Let's say that I have a hydraulic, not a hydraulic arm, an arm attached to a roller here, and there's a hinge here, something like this. And I told you that this arm is having an omega that way. This is the omega. All right, so I told you this is point O, and this is point A. Let me make it the same thing that I have here so you don't get confused. So I have this point is C, A, B, and C. All right? Okay, so tell me, bar BC is making translation, fixed axis rotation, or general plane motion? Fixed axis rotation, because it rotated around this point. How about bar AB? That's a very tricky one. Translation or general plane motion? The thing is, point B is free in the space. I didn't restrain point B. Like if I put this, something like that, and I put roller here and roller here, so I'm restraining this point and restraining this point, that means this part has to move in a horizontal way. This is gonna be translation, but I'm not making this. I'm making this, that's like the older trains, is something like this, like there's bars and, okay, anyway. So I have here, this is point B, and point B can't move in the space, so basically this bar is, if this goes that way, this bar is gonna go up, something like that. And once this is go up, then new movement is gonna be that way, this bar is gonna be that way, all right? Okay, so this is the absolute velocity of B. This is VB, and if I want to find VB, knowing this omega, VB is equal to this omega, omega BC, cross product RB with respect to C. This R, this is the R. B with respect to C. I multiply the omega cross product by B. Alright, so that's the first thing. The thing is, A is very easy because A is always going to be in this direction. There is no way that it's going to go any other way because it's restrained. So VA is always going to be in this direction because it's restrained with this roller. So it's going to be moving that way. So I know VA. But what if I want to know the velocity of B with respect to A? Here is the velocity of B with respect to C. And right now I'm trying to find the velocity of B with respect to something that is moving. Yeah, it's moving horizontally, but it's still moving. Okay? I mean, like it's like directed velocity, but it's not constant. This point is still moving. So basically, you draw a line from A to B, and this is gonna be your R, the new R, RB with respect to C. And then, knowing the omega direction of the new R, omega AB, that is the omega of the new body, because if this one is going to move that way, this arm is going to move that way. You drew a perpendicular line on this one, and this is going to be the velocity of B with respect to A. Alright? So any point, like any point attached to two bars, it has two velocities. One come from the first bar and one come from the second bar. Like let's say that this one. So, since this point is attached to two bars, this point have a velocity with relative to this point, and have a velocity with relative to this point. And that makes sense. Like if I'm sitting here and there's two bodies are moving, if I'm measuring the velocity from my side, is different. Like if I'm measuring this, like, or two bodies, like if I'm sitting here and one of you is sitting there, and there's a car is moving, measuring the relative velocity from my side is different from your side. The body is going towards you, but the body is moving away from you, and it's moving in different directions. So basically, if you are getting the velocity of this point with respect to this point, is different if you are getting it with respect to this point. And let's do this. I'm saying that this point is fixed. So I draw a perpendicular line from the point that I want to find the velocity at, and then the omega is in this direction, so the velocity is perpendicular in this direction. If I give you that the omega is in the other direction, so the velocity is going to be in this direction. That's V. And let's say this is point A, B, and C, so this is going to be VB with respect to C, right? Right? If omega is going that way, and if omega is going that way, the omega of this body is going to go that way, because it's going to go down as well. Alright, so if you want to find the velocity of B with respect to A, draw a line from A to B, and then draw a perpendicular on this line in the direction of the omega, and this is going to be VB with respect to A. And if you want to find these velocities, VB with respect to C, this one is equal to the omega of the bar BC cross product by RB with respect to C. If you want to find VB with respect to A, it's going to be equal to the omega AB cross product with RB with respect to A. So it's a general rule. Velocity of BC is equal to the omega of the body BC multiplied by RBC, the radius BC. And that makes sense. If you have a body, and this is B and this is C, and you want to find the velocity at C, so the velocity at C is equal to the omega of this body multiplied by the RBC. But if this one is attached to another point here, and this point you want to find the velocity with respect to A, so the velocity with respect to A is equal to this arm multiplied the omega of this arm, okay? And always the velocity is perpendicular to the arms. Like if you have an arm that way, so the velocity is perpendicular to this arm. If you have an arm that way, so the velocity is always perpendicular to this arm. And same rule applies for the acceleration, okay? So next time, I'm gonna do some example on these things so we make sure that you guys understand how to do relative motion. I'm gonna upload the quiz like in an hour or two. It's gonna be open until midnight, so you will have time to do it, right? It's gonna be on, by the way, this is part of it, but I'm not gonna give it as difficult as this one. You will have to map velocities, but not relative velocity, okay? Definitely, if you understand this concept, you are gonna kill the quiz. Like, you understand if it's a relative. Today. Time?
Say it again?
Do you have extra time? I mean, no?